All right, good morning. Good. Offline for a minute, but I think it's... All right, welcome. Morning. Well, thanks for watching. If you are new and don't know, my name's Tim. I go by Foamy Guy, and I stream at this time, around this time, usually each week, 10 a.m. Central Time, working on some stuff related to CircuitPython. If you are, in fact, new and don't know what CircuitPython is, you'll learn more about it here at CircuitPython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. You plug them into your computer, they show up like a thumb drive. You can edit some Python code on that thumb drive, and when you save it, the microcontroller will actually interpret and execute that Python code for you. You can then interact with all sorts of other external hardware, including some microcontrollers like the, let's say, Matrix Portal, which the original one, the microcontroller is a SAMD51, but there is a coprocessor that is an ESP32, which allows some interconnectivity between those two, and it allows you to write programs that use the internet in this case, or Wi-Fi. So CircuitPython.org, you can learn more. As always, thanks to Adafruit. Adafruit is a hardware and software company. They manufacture lots of microcontrollers that support CircuitPython, as well as all sorts of other little doodads and things that you can hook up to your microcontrollers to do stuff with, to make fun projects and things. So thanks to them, they make CircuitPython possible by paying a team of developers, including myself, to work on that project, and they publish all the code under open source licenses and everything, which is obviously very cool, I think, although I am biased. Yeah, support them. It helps support the project, and I appreciate everyone who does. Today, I'm jumping right in. I am trying to test out the latest version of this. I saw this morning there are some new commits. This is an issue that I have been looking at for a little bit with the newest versions of Nina firmware, which support ESP32C6. If you are new and don't know anything about what I'm talking about, Nina firmware is what would run on the ESP32 back here. In this case, where it's a coprocessor and it's allowing this other main chip to be able to use the Wi-Fi, Nina firmware is what runs on the ESP32 in that case. The newest versions also support ESP32C6, which is what is built into the Fruit Jam, which is kind of ultimately the aim here. But this issue can test on ESP32 as well, which is where we're going to start because that is what is easiest. So we need to upload the newest version of Nina firmware, which was committed recently into this branch onto my Airlift Featherwing, which I have here. I don't have the camera set up because there really is not a whole lot to see, honestly. I'm just going to be plugging and unplugging feathers into a couple of different things in case if anyone is just extraordinarily super duper interested in what is going on here. I have an Airlift Featherwing. I have one of these, Airlift Featherwing, and I have a couple of feather triplers, which I'm moving it back and forth between. One feather tripler has a feather RP2040, which I'm using as a Nina firmware programmer, essentially a ESP pass-through programmer. So what that allows me to do, I'm about to plug that one in right now. I have put the Airlift Featherwing onto that tripler with that RP2040 feather, which is set up as the pass-through programmer for me. What that then allows me to do is, out of Chrome, because it does require Chrome, is back to saying offline again, but also says, excellent, goes on. I think we're just running, like, this gets awkward. Focus. Anyway, here we can go to ESP tool. This is a program that allows you to, this is a website, in fact, which when you use it in Chrome allows you to program ESP microcontrollers, such as the ESP32 that we are having on the airlift featherwing. I believe this needs to be on. I believe this needs to be on, and I just turned it off for MagTag last night. I believe is the situation there. I'm gonna double check though, just because I don't actually know for sure what it does and how bad things go if you do it wrong. Airlift featherwing. All right, here, upgrading firmware, upgrading with an RP2040. Okay, we want this on. A reset for pass-through. Well, pass-through, I guess, is what we're doing, so yeah. No reset for pass-through, we're gonna turn that on. We are gonna click connect, because now it should find nothing. I think this is... Need to close this for now. I suspect this is like... may interfere, I don't know. Pretty close. Actually trying to open. There we go. I don't know. Fluke, but we got it the second try. I didn't only get really well. I closed Arduino, I guess. Maybe that's what did it. I don't know what did. Okay, so this is now connected into the Feather RP2040, which is gonna allow us to program the airlift. Oh, how do you recommend I write a text file with IMU readings against and somehow be read on my computer later? I would probably... I don't know what IM... Oh, MPU... help with channel, where you can get helped out with CircuitPython questions. All right, where are we at here? So we need the bin file in order to flash onto this, which we get from here. Actions. Artifacts. I don't know why that's not in the other one, but it's here. So we want release Nina firmware ESP32. Zip that. Bin file. I just copied it. Why? That's not what we need to do. We need to choose it in this. For one, that's the new one because I've done this before. That's selected, and then if I recall right, we need to some of these. Scroll it. If I recall correctly, we need to press erase and then press program. File, click program. Got erase. File, click program. What's up, Johnny? Nice to see you today, my friend. This works out, then I will try the C6. I've been having trouble figuring out how to flash firmware to the C6, so it may turn into an adventure in trying to flash the C6 and not succeeding, but we'll see how this one goes first, since this one is easier to flash because I already know how, or at least I've already done it before, where it's documented and everything. We don't have to try to muck with the code, and the other one we do have to try to muck with the code to get a bit to get it going, I think. So cross that bridge when we get there. Now we'll wait on this one. It's gonna write, it's gonna do a hash, leaving. All right, so run the firmware, we can reset the device. So I am gonna unplug this. I'm gonna move the feather wing back over to the feather that is set up to actually run some code to test it. One happens to be a feather RP2350. Matches the fruit jam. Nice bit of foreshadowing. Airlift into there. Put this in. That's got CircuitPython on it, not the pass-through thing, so we can disconnect this. Then we're gonna want TO. I think I'm gonna run. Gonna want TO. Okay, so this is currently. So this is a Wi-Fi test thing. It's going to connect to the Wi-Fi. It's using the ESP coprocessor that we just reprogrammed. Gonna basically join the Wi-Fi, and then it's going to try to request. Right now, it's going to try to request a single file from the network. This JSON file, which is Adafruit Product API. Run, and it will print the version, although the version says the same as the currently released one. Okay, so that was a success. Nice. The prior one was also succeeding most of the time, and really what we are going to do now is actually swap this out for this. I've basically set up a copy. Well, I've set up a server which has some files that I can serve from it. And it's my server, so it's not important. It's not doing anything useful for anyone else. I can kind of hammer it as hard as I want, as fast as I want. No one else knows or cares. We are gonna do that, which is this loop here. This is so basically what I did is these size test files. There's like every 128 bytes from, I don't know, maybe 1K-ish all the way up to 16K or something like that. There's a file for each one of those. And this one is not getting all of them, but it is getting everything from 1024 up to whatever 5 times that is. So it's getting like everything from 1K to 5K, 128 byte intervals, because that's how big the files jump each time. It's going to request each one 5 times, and it's going to save all the results in a dictionary which we can then later crunch the numbers on to find out the average, like not really the average, but the success rate, essentially. Save this thing. Maybe we should. I don't need to worry about it right now, I guess. I can't. The other nice thing about this being on my server is that I can go to the server and look at the logs from the web server. So we could see, like, one of the things I noticed in the logs was that sometimes on the client side, the request fails, but on the server side, the request has succeeded. That's kind of interesting. Okay, we're gonna basically let this do its thing, I think. Thing I will need is, I think, the code that calculates the final rate is like normally saved on the other device. But that's running pass-through right now. But I would have surely backed it up before I did that with it. This code actually, it's not, there's nothing special, but it just goes through the dictionary, the same dictionary that this is going to print when it's done. And it calculates how many, what percentage was successful out of, you know, those 5 requests each to files. So far, we're looking pretty good, though. I don't think there's been no failures so far. So the last one, the most recent version from the PR, when I tested this yesterday, it was like 90-ish%. Actually, probably it would be the same. Or it's the same data from when I did that. 92%. But this one we're looking a lot better. One so far has not failed at all. We are about 2/3 of the way through, and it's going from about 1K to about 5K. This test code is. That is looking very positive. So we might, in fact, be diving into the C6. So let me pull some browser tabs that are gonna be useful for that. Different thing. Well, that's not soldered. I'm probably getting tried today. Theoretically, that's something. Basically. For jam pin out. My dark mode works here, but not in my other browser. Weird. For jam pin out in schematics. because the pins that are connected to the coprocessor are important for programming coprocessor. We're getting pretty close. That is either the last one or maybe one more. Last one, okay. And I think that's 100%. I don't see only fives after a quick glance, but let's rely on a quick glance. Boom, 100%. Nice. All right. I will let it run some more. Like that's one test still, which is good. Well, I mean it's one test of, you know, however many times 5, but I think I will test it some more, but I'm pretty satisfied that this basically is fixing the problem because it was very apparent we were getting more failures yesterday under the exact same conditions. And now we have the new one. Didn't fail at all. Pretty satisfied. Say that it's fixed there. So the true goal here though is this one here. C6 on the fruit jam. And in order to flash it, it's trickier. I don't think I can just connect it to the feather that I'm using to program the other one. Or if I can, I don't know how to wire it up. So instead, I think we need to have on the fruit jam the pass-through program, essentially the same program that's on the Feather RP2040 that I was using on that other one to program it, but we need to get that onto the fruit jam, and we needed to get it to use the right pins. And that part has proven a bit tricky so far. But I have the fruit jam plugged in, is on currently. It is most likely not ACM0. I'm just going to unplug it and replug it, and I suspect it may come back as ACM0. We should kill TO, actually. Okay, it did come back as 0. Okay, I was on 1 before. Okay, we definitely don't want that running, though, because that's going to interrupt stuff. So no TO. We are on 0. It's not going to be a Pico 2W. It is going to be a fruit jam. It is at ACM0, yes. Okay. So let's verify this. Yeah, and so fair warning, Arduino is not necessarily my stomping ground. So if you are more familiar with Arduino, then you may yelling at your screen about how much I don't know what I'm doing. Yeah, there we go. So it reset itself. It wrote some stuff. It's done uploading. And so part of the trickiness here is we can't get output very easily. So we have the NeoPixel, which shows a color. Right now that's on white. And I believe, theoretically, if all of this was working, we could try this. Let me try actually something different first, though. Let me try BIM. Why that uses also device workspace. Cool. Tool -P. Okay, but is Arduino still Maybe my problem was that Arduino is still open, right? Like I was failing. I didn't actually check to see if it would have kept failing or not. We only tested it once. It could have been a fluke, but I suspect this has the serial port. I don't know how to close it besides like closing the program, which feels bad, but whatever. Let's do that so we get the fairest chance. So ESP tool path, the path to what is now the fruit jam. Currently the light is yellow. It was white on boot up. So it may have changed actually when I closed Arduino. I'm just gonna press the reset button. So it came back up to white. I think we want to start from there. That's what it does when it first powers up. So exactly when it changed to yellow. So path ACM 0, and then we're just gonna do chip ID. So I got bright white, I got yellow. Now I get connecting dots. And unfortunately, I'm thinking we get no dice. Failed to connect to expressive device. No serial data received. There's troubleshooting there. Okay. We're going to do some of our own troubleshooting. And the first thing that I am going to try troubleshooting is this right here. We need to, before no reset, dash before no reset. Before no reset. Is that on ESP tool thing? After, before reset. Oh, that's what the switch. Is that what this switch is? No reset. Yeah, let me leave this open and let's see what happens, because it would be nice to not have to do that, honestly. Yeah, thank you, by the way, Ty. I appreciate the help there. So and then all the options go up front, I think, right? Matters where we put them here before set words dash reset. Okay, probably I need to reset it still too. So I'm actually, this is maybe gonna fail. I'm just gonna reset it with the button. Then I'm gonna do this again. Yellow again. So far it's still the same. Oh wait, what does this say? Pre-connection option, no, not a bootloader or flasher stub. So that still failed again. I am gonna close Arduino again. A little paranoid about this. Okay, but it was still yellow, so I'm gonna let this fail again. I'm gonna reset again. Run this again. Arduino is not hogging the serial port if you don't have the window open. Okay. So we went to yellow, doing its thing, but it's still not finding. Okay. All right, so we'll reset one more time. That's gonna get us back to white. I will leave Arduino open for now. Let's do that. Same as Adafruit, same as the web tool does. Okay. So the next thing to double check is, are these correct? And the reason why that is on my mind as a potential reason this might not be working is because I don't know how Arduino pin definitions work exactly. Pull up this link. Okay, so FruitJam pins Arduino has serial 1 and serial 2, but serial 2 looks like these are duds or whatever, right? 99, I'm assuming that's fake. So serial 1 is TX8 RX9, and I'm pretty sure that's what we want to use because here, TX RX GPIO 8 and 9, that seems good. And then SPI, we have SCK Misomosi, so that's 30, 28, 21, which does match SPI 1, 30, 28, 31. But I don't know for sure. I don't know for sure that this is working, and I don't know for sure that these are selecting the correct pins. So that is the next thing that I'm going to try to figure out. The no reset thing is definitely good to know, though. Do I need the reset pin? Well, I'm going to do the reset pin because all the rest of these have it. So theoretically, well, this one, it doesn't have RP2040. Slightly suspicious. Like maybe because I did notice like that here these are two different pages with a bunch of feathers and things listed here. Then a separate page with RP2040 and separate UF2s. So one thing that's odd, this says for feather RP2040. Oh, if. That changes the entire thing. Okay, if you are not stacking, which I am. None of this matters. Okay. Get to the bootloader, put the UF2, basically. Download the thing, flash it. Okay. But the part I don't necessarily know, like, is this a different UF2 than the ones on the other page because it's got different sauce in there somehow? Or does it just happen to be a different page? Let me check actually one place here, actually. So I got this from linked me to okay, this is the pass-through. And learn guides. 32 Arduino, serial ESP pass-through. Here, if there are any. Ooh, did you see that? I saw that. So pass through RP2040. This is way different. This is a lot less stuff. And it defines the pins differently, which might be like the whole crux of our problem here. Okay. Let's figure out if this is taking effect somehow, and then also we can try to figure out which pins these things are using. That's a bit tricky to figure out because usually I would just print it, and that would be easy. But the problem is this is using serial, place where you would normally print, for the pass-through stuff. So we can't print there. That's going to wreck the whole pass-through thing. So we need to have another place to print. And I think what I am going to do is use software serial, like just set up another... basically set up another channel that we can print out of. So we need to figure out what pins that we want to use. And I want to use 2 pins that are available on this thing that are not being used for anything else, ideally. 43 and 44 are labeled as TX and RX. Trying to do UART basically, so that seems good. None of these use 43 and 44. There is 46 for chip select, but that's different. So those seem good to me. We do need to figure out the orientation here, so... okay, so the right row here is on top because it matches the silk screen there, right? So 5 volt, 3 volt ground, A1, A2, A3, blah, all the way up. That's the top row. So truthfully, I really only need transmit because I'm not trying to receive anything inside of this. I'm just trying to print. So I only need transmit on this side, and that is the pin that is labeled A3. I have a USB serial cable, FTDI thing or whatever, or the exact proper name for it, but it's a USB cable and it lets me talk to UART stuff. Maybe not plug it. So that is the top side, which is away from the USB. Should I plug in ground first? Ground first. So ground is the third one in on either side. Doesn't matter, but I'll use the top side, the side opposite. 1, 2, 3. Ground is number 3. And then from there, we want to get to TX, which is 1, 2, 3. It's the third pin down from there. So skip 2 and down. All right. That's plugged into those pins. USB plugged into the computer. All right, I'm gonna go feed the cat. Otherwise, eventually the cat is gonna get impatient. BRB. Okay. It's food. Another new one. Okay, so USB 0, that's probably the cable. We can open that. So far, it has not seen anything. But what we're going to do is in here, we need to begin bug serial. And just print that. That's fine. That compile. Sure, we can get anything out of here. I do need to be careful to never open serial monitor, especially if that will mess with it. I did not see anything here. Oh, I did not ever change the pins. I never changed the pins. These are on 2 and 3. Lord only knows what that did. So we want well, I want 43 for TX and technically 44 for RX, but really I only care about TX. Still no output. Oh. This be used by anything. So it's a lot harder to troubleshoot if I can't print anything that I can see. We really need to get this to work to be able to do much else without just like blindly guessing. Could it be like too fast or whatever? Do I need to maybe add a delay? Like I feel like I've had a thing before where I needed to delay for printing to kind of give the computer time to like realize that it connected. But in this case, the connection is USB cable, which is staying connected. Get this. Connected to the pin labeled A3. Supposedly GPIO 43. It is supposedly TX. We not choose that since we're doing software serial? Right, surely it would let you do that. We did begin. How do you sleep? Just like 8. Semicolon. I mean, I guess maybe the cable is not used. I'm gonna unplug the cable. That disappeared. I'll plug the cable back in. That reappears. That has to be, I think that has to be the cable. No, you just get nothing. I mean, could it be the wrong thing with T? Like I've ever had to specify. Default, okay, maybe. We could either increase that or lower this. I guess I'll. This goes options. I'm just gonna reset button. Okay, gotta set the baud rate correctly. Turns out. Okay, that's good. Being able to see anything is a very good first step. So let's now try without this, first of all, because I don't want to wait for 3 extra seconds if I don't have to. Okay, perfect. We do see that. Very good. Okay. Now, let's do this. But just if. So that we can try to figure out if this is seeing the right board. I think it is, because I tested this with a more minimal example the other day. But we are in kind of like validate everything mode right now. Running on Fruit Jam. Okay, very good. So presumably all of these things should be set. And I mean, like the NeoPixel pin, I think must be set correctly because the NeoPixel is turning colors. But the next thing is I want to see the pins that these things have. I think I can do that by Okay, let's do serial first, and then worry about SPI in a minute. Okay, so this must be dim white, bright white. Wait a minute. There's serial.begin, but then there's serial ESP.begin. Wait a minute. Right. Because it uses both. It gets data in from serial and it writes it out ESP serial. Okay, I think I'm caught up. I don't know if we need that or not. Yeah, I don't know if we need that or not. So ESP serial, that's what I'm. That's what I'm more interested in. Pretty sure. Because we want to make sure that is on pins 8 and 9. Because we know from right here, 8 and 9 are what those need to be on. Now, I do wonder, are we for sure getting... Now that I'm realizing by default it uses 2 serials, right? It's coming in through serial. I wonder, I mean, surely that's set up fine. I would assume that's fine. And we are getting this, right? I'm pretty sure, because it does go dim and then bright. White. So this, let's let it begin, but then let's print the pins that it's using so we can try to make sure that it's using the right pins. So we can debug serial.println. Oh, just doing it maybe this way. So print this and then say, I don't know if that's going to work though. This is a completely different, begin. This is, how can I print the pins of a serial? Serial ESP32. Yeah, like impossible to search for because serial.print. This is kind of interesting. Maybe we could be checking multiple ones, I guess. Oh, man. How do we print the pins from a serial port? Whatever this thing is. I don't really know what serial 1 is, but I want to know how to print the pins on it. I assume I cannot just pass it to print by itself, probably. This is gonna have all the same stuff. All the same stuff. But it's got set pins. How many get pins? Set pins, but no get pins. Has inverts. Polling modes has set pin out where you can. Has 2 pins. Can't get the pins once it's. Standard method to print the pin. Check if the core supports pin query. Maybe 2040 does sometimes. Okay, so serial 1. Yeah, it's really unhelpful that this is like a magical thing that gets filled and you can never verify what it is. I'm sure it's the right thing, but like in troubleshooting mode, being able to verify that it's the right thing is super handy. But we could try this, I guess. This says 2040. I don't know if Arch 2040 is that. Does that count for 2350? Can you nest? I don't know if you can nest like this. Maybe I shouldn't. Doesn't work. So the other option is just pin serial 1 TX, print pin serial 1 RX. Oh, but should we do this after this, maybe? Run that, and I will BRB. Okay, that has written. Light is on. Let's run anything new. Print anything new. I just press reset button. Oh, it doesn't print anything. Okay. So that's helpful to know. Does that mean it's getting... Does it still go to yellow if I do this? Yeah. Oh, I put it after begin. Okay, this must not return until something connects. So this connected. This returned. This happened. We got our pins. Hopefully, maybe. They're correct. As far as I can tell. Okay, so the only other thing I can think to check here then, well, the next thing I can think to check is going to be the SPI pins. Supposedly we can print this way, although I don't know if... Unclear to me, like, if it uses the SPI as part of the flashing, or... But I'm not really... I don't... Was it called SPY? It is, okay. Definitely SPY 1. Although I have tried SPY as well. SPY 1 was not declared. Why did the code run every other time I ran it? I did not just change this. This has been this way the last several times I ran it. Okay, we're getting similar at least. So this is not declared, and that's our problem, probably. Is it? Does it know that it's not used? Does it get compilered out because it's not used. If I turn these off, but if it's not used, does it matter if it's wrong? It is used. Oh. Not used. Is it declared if it's not used? Okay. Go back to here. Yeah, I mean those are wrong if it can't find it. No, don't want to buy any best viewers. Come on now, friend. Gunfighter? Devoted gunfighter? Gunfighting around here, okay. Okay. So I'm gonna go and say then maybe we should be using this. But I don't know if this will run. That's using standard IO USB in it. All right. Are these what's the order of these? RGB. So this is yellow. So it gets to here. Could this need to be 2030? Is that a thing? Oh, it looks like you are allowed to nest these. This could be our problem. It seems like low-hanging fruit to just try this, I suppose. Right. This is here. So my next straw to grasp at. Okay, let's double check all the pins. I've double checked the pins like 4 times now, so like a quintuple check more than a double check. We're gonna do it again just to make sure. I wanted that. Yeah, I do definitely note here nothing, no spy. Doesn't say anything about spy. It is odd that the other script has spy, but just doesn't seem to use it. We could print these pins, I guess. So in addition to validating here that they seem correct, we can also print them and make sure they look correct from the code. All right, so 8 and 9, we are printing. Those seem okay to me. Peripheral reset. Root jam here, reset pin 22. GPIO 22, and it is peripheral reset, and it is also ESP reset. They're both same pin there. So SPI Wi-Fi chip select. ESP chip select CS 46. Those two are good. SPI Wi-Fi ACK, busy or ready. So there's a busy here. I assume that means busy, since that says AKA busy or ready. So I have 3 there. Seems correct for GPIO 3. This one is disconnected. And then NeoPixel pin is 32, which seems to be working fine, so I don't think we care about. Let's make sure this is set on 46. Maybe not somehow. Fathom why that would be. Bit of a loss here altogether. Why is it SS instead of CS? And a good tiled window instead. Uploading, and that's there. So we do this. $46. There. Check the other ones as well. Reset and ACK. I especially see no reason why these would not be set. But it's odd to me that it's reset in as well, instead of like it's consistent. It don't matter. Bing. It's gonna open the browser. All right, ACK 3 reset 22. Busy 3 at 22. It seems like all the pins are fine. So these all get set up as outputs. It says manually put it in upload mode. Digital write GPIO 0 to low. So there's, I guess, one thing is we don't have GPIO 0. Is that important? A lot of these other ones don't have that. But this one here does. Let's try to discern if that's like something we could use, then we could get. This is the gonna tell me. Sure. Pretty sure. So this is the Fruit Jam schematic. So, but then this is the coprocessor on it, and IO 0. And for one thing, it doesn't say boot. So this here says ESP boot. Could we need to set, because GPIO 0, I think, is often the boot pin, I thought. Doesn't seem to be 0 on this one. Does that mean this is a... Does that mean this is a hole? Not actually sure what this part, like what all of this means. I don't necessarily read schematic, truthfully. Symbols. Come a long way though. Closer. Active. Busy. Over there. Interesting. So I wonder if I set GPIO 0 to IRQ 23. anything different happen? Maybe at some point it would be good to check here if we're actually making it inside this thing, since I just kind of randomly changed that. And I'm not sure if it's like, shit, the thing I changed it to. Okay, that did something different. Didn't work, but it did something different. So this time it went to red. The last time it was always dim white, then bright white, then yellow, and then nothing else. This time, dim white, bright white, yellow, red. Immediately to red after yellow. All right, and this is RGB, so that's red right there. And LED built in, I assume, is the red one next to the USB port. That is also currently high. That is currently on. But I mean, this is... We have red on the NeoPixel and we have this on. So how do we know? Like, how could that be possible, first of all? Because this is if... And then if this, then set this. But else do this. Semicolon. Why did that compile when it doesn't have a semicolon? It's not going to get executed. Must be like the spy thing, right? It's like optimizing out code that's not going to get executed. Maybe this is wrecking us somehow. Yeah, so that didn't happen. So this says NeoPixel is blocking. Maybe we should just remove all the NeoPixel stuff. Really, the else block gets executed. That's interesting that... I guess that's the crux of compile time, though. It's interesting that you can tell by putting a non-semicolon thing without running, you could tell which ones of these will affect your code, which is kind of nice. All right, so that's just on the else block the whole time. And in fact, that's slowing this down a lot, so it's making it fail slower, but it will eventually still fail, I'm sure. So I did change these earlier. Let's put these back and see if it goes inside there that way or not. And then probably we're gonna have to turn off the debug print as well, because it's making it lower too. I assume that's not gonna help. So we're inside the blocking workaround now, and the NeoPixel is yellow, and the built-in LED is off. What is Adafruit? Asks Sanu on Discord. Adafruit is hardware and software company. They're based out of New York, the United States. They make all kinds of electronic devices, microcontrollers, and things that you can hook up to your microcontrollers to build fun projects and neat things and stuff with. They're just a smattering of the products that they have. So they make like DIY electronic stuff essentially, and they pay developers like me to work on software for those things and then contribute it to the open source. It's awesome. I would say they are awesome. But I am biased. As noted, they pay me to work on open source software. I find that awesome. Okay, this. So we do make it all the way into that inner if when we use 2040. So we don't want to switch that to 2350. Presumably that should take care of the pixel blocking problem. I do note that right now my built-in LED, I believe, is off. Pretty sure it's the red LED that's next to the USB port, and it's definitely off. But this one turns it back to low. Okay, so adding the GPIO 0 thing did not actually make any fundamental difference in the behavior. It was different for a minute, but it was actually because I had changed the 2350 arch thing. I think you are one of them. You are correct. Okay, and then this one is made for ESP20. No, is made for RP2040. It does a handful of things different. It does not rest. It doesn't mess with SPI at all. It doesn't use bus objects. Instead, it declares 2 pins for TX-RX, and then it doesn't have SPI, like I said before. It does actually. It uses UART 0. Yes. But it uses these, and this didn't compile for me. This is like C, though. I think this might not be our... I think this isn't not Arduino. Yeah. I think that's not Arduino. I think this might just be like Pico SDK, I guess. Yeah, we need to do some of this, I think, to make that work. So this is promising, truthfully, because I assume that in June when Lady Ada did this, probably did it for the fruit jam. We are maybe on the right track here. But just failing to get it all correct. So I think this is the one we would want to use, not the RP2041. That one's not Arduino, I don't think. Can I... How can I define one of these with pins? I'm still not entirely convinced that this is actually hooked up to the right pins. And it would maybe kind of... killable. I don't know. I mean, we are... that. Yeah. Oh, how could I validate... Well, okay, why do we need the chip select pin if we're not using SPI? Does this get used by anything? Gets set to an output, but not used for anything besides getting set to an output. I gotta wonder if that's necessary. One thing, slightly. So this one is while there is data in the USB port, we turn this on and we write the data to the coprocessor, and then this one is vice versa. While there's data coming from the coprocessor, we write it to the USB. So sticking on yellow actually makes sense because this is no longer going to change the colors. And we know that we did actually get into here because this got printed. Now it's only in this one down here. It's commented out up there. It's only in this one. Okay, now that's interesting. So presumably this was never available, right? That means this was never available. Because we know these were both true. So if this ever was true, then we should have definitely printed this. Now, one thing I don't know is why was this not on? That's setting it to high. And we know this got printed before. Presumably that should be high, but no. Debug serial.println ESP32 serial available. Okay, I'm guessing we never get to here, and that is making me even more suspicious that serial 1 is wrong for this. So I think the next thing I'm going to look up how to do is how can I make a serial object explicitly with pins instead of using serial 1, serial 0, whatever. Sorry, my friend over in Sonu, I'm not sure exactly how long ago you asked this on YouTube, but I just looked back. So your question, you said, can you suggest me any application to program my Arduino Uno using mobile phone with updated version of smartphone? Don't suggest me Arduino Droid. I cannot, honestly. I don't do any mobile phone Arduino programming. Frankly, I don't do very much Arduino programming at all, which you could maybe tell by how much I'm floundering here. If you're more familiar with Arduino, so yeah, unfortunately, I don't have any suggestion there for you. Sorry. Yeah, I don't know. All right. So this should print if this ever gets to available, but I'm guessing that it's not gonna. Yeah. Okay. Okay. I think that's got to be wrong. I think that's got to be wrong. I tried to print the pins for it, but I'm not convinced that serial 1 is actually pointing to those pins, basically. So how do we... So the weird thing is, though, it's not a we need to, like, initialize a hardware serial instance. But I have no idea if that's, like, a thing at all possible. So in the definitions here, it has pins, and they never get used anywhere but just being declared. And The only place that ever say serial 1 are those. So Arduino initialize hardware serial. Not an example. Did I not click a thing that said example? Not. Okay. Is it not possible? It's not possible. I mean, these all just assume it exists and go. I really wish you could print the pins. That's like, it's very bizarre to me that you can set new pins. I can set the pins I want. Basically what I was asking how to do. Is that true? I can set the pins? I can't. This. XRX, so we can do... If we do that before we begin, then it should definitely be on the right pins, as long as that actually does what it does based on the name. Basically, you just still got no available. Let's turn off the GPIO 0 thing. Like, possibly this could mess it up. Nope. If the chip on a bootloader or flasher stuff. Yeah, we must be... I don't know. We must be failing to get it into bootloader mode, I guess. It's weird to me that we got to hear. I swear we got to hear and this spammed, but this was not on, I thought. That I'm also basically out of ideas. I might be admitting defeat for the time being. We were able to test the ESP32 one though, which is nice. I would love to get this one tried out as well, but and I'm sure it's like just something simple I'm doing wrong, but having no luck figuring out what it is. I'll have to ask this week how to flash it on the fruit jam. But yeah, right now the built-in LED is off. Looks to me like unless that's the wrong LED, but I think that's the right LED. It looks off to me. It's on unless it's the green one, but I'm pretty sure the green one is power. So that's odd. Since we know we're getting to here and we know the next thing should be turning that on. And we know that we're not getting to here, which is where it gets turned off, so like getting this eventually stopped, I guess. Alright. I think I'm gonna call it a day for now. I'm basically out of ideas. So I'll just have to ask. But this was a good exercise in troubleshooting, especially setting up this whole separate debug serial thing. This is not a thing I'd done before, so like if nothing else, frankly, I'm glad that I learned how to do this and practiced it and have like another tool to throw in the tool bag. It could come in handy one day, I'm sure. I'm not sure what all it's expected to send back. I mean, I guess it must be expected to send back its version and all that stuff it prints at the beginning. There's a handful of things it prints right when you first connect. I don't know. It could be like maybe there was some like my version is not the final one. My version is not the final one, and it's possible this pinout is for the final one, so it's possible maybe maybe something got switched up. In fact, I know for sure something in the I2S got switched up. I thought that was the only thing. Yeah, totally. This is the on LED. It says on there, and then L is the built-in LED. So that's totally not turned on when this code does run. So that's also weird, the fact that we turned that on, but it seemed to actually be on. Yeah, I almost wonder, thinking like we might have to use that. Boot zero. Right now we do have this on -1. I tried to put it to 23. based on what I saw here. But I do notice here on the main chip, I mean, maybe these are holes. There are 2 holes by the USBs. And this is the same icon as this. Anyway, though, we have ESP busy here, GPIO 3. We have TX and RX are here. They're not labeled explicitly as ESP, but according to this at least, they are attached to the ESP. This has I2S ESP IRQ, and then peripheral reset. So that doesn't actually say anything about boot here. And then there's really not very many other, basically nothing else ESP. There's nothing else labeled ESP. Really, the only things on this side labeled ESP are busy and IRQ. This kind of feels like it might be part of the puzzle. But I'm not sure really what the diagram means exactly. But there's this hole right here. There's like a through hole on the board. But it's not labeled. And then there's these 2 through holes over here as well. So possibly the one by itself is this, and the other 2 are these. But I don't know for sure. And then even if that's the case, I'm not sure really what to do with this. I guess maybe I would need to jump that to ground. but we tried setting ESP IRQ. That didn't make a difference. Did it on this, which it would have put that to low. So by itself, that didn't do anything. So I don't know. So let me check one more thing. Is ESP IRQ? I mean, surely it's not, right? No. I was gonna say, is ESP IRQ broken out on here? Like, could I multimeter to check that hole, that through hole right there with it? But it's not. Can't do that. I mean, that is like the last thing I got any kind of plan, any kind of idea at all, is maybe possibly that is ESP boot, and maybe possibly I need to like explicitly tie it to ground in order to make sure that that's going into bootloader mode. And whatever this T junction going on here, whatever that means, does not mean that you can set this low and it just works. Seemingly, that's my guess right now. I could measure the voltage on that, I guess. We could see if we're getting no voltage or 3 or 5. Presumably we'd be getting 3 if the diagram is correct, because it looks connected to 3 volts through a resistor. So yeah, 2.86 I have right now. Okay. I'm gonna get a wire and try this. Hope that I don't ruin anything. But I am probably wrapping up. Be perhaps anticlimactic, because it's either gonna work and I'm gonna wrap up, or it's not gonna work and I'm gonna wrap up. But I do need a wire to not seem to have a random wire here. So BRB, I'm gonna get a wire. But if that is actually connected to 3 volts, we don't just want to connect it to ground, do we? That wouldn't be good. Okay, that lends a little bit more credence to this. So I have also an older revision of the Fruit Jam, which has no coprocessor. And on that one, that little through hole thing is not there. The other two are. The two that are down by the USB are. And again, we saw here, there's those two, and those are on USB stuff. They're down by the USB, so I'm thinking those two might be those two. This one does there's no hole there on the other fruit jam, so this being tied to the ESP is looking more likely to me. I'm honest, I'm a little scared to just jump it to ground. See, goes too wrong. We should have code that doesn't do this, though. At least if it works. Don't want it to get messed up by that. So let's turn that back off. I kind of do want these, otherwise like we don't really know if we got anywhere, kinda honestly. So you probably would not be able to use it for an actual flash, but we can maybe see if we get one step farther. Would hopefully tell us that we potentially got to bootloader mode. All right, gonna get this ready. That's interesting that it didn't print the whole thing, kind of. I'm gonna just reset. Okay. I don't really like the fact that that did not print everything. I've not changed anything. Ground are next to each other. Okay, well, we know it printed some things when I did this. Okay, that's printing. I don't know why. I don't know why we got half of that before, but reset. I am gonna take this wire, which I have connected to ground, and I'm going to gently this little hole. The fruit jam did not instantly turn off or do anything terrible so far. I'm gonna run this, and doesn't seem like anything different happens. All right. I am definitely all the way out of ideas then. So. Yeah, I'll have to ask. In any case, thank you for hanging out. Anyone who's still here, appreciate you all hanging out. Appreciate the folks in the chat. I will be back at the usual times next week, I'm pretty sure. Deep dive on Friday. It's 4 p.m. Central, it's 5 p.m. Eastern, 2 p.m. Pacific over on Adafruit channel, and then here on my own channel, I usually stream Saturday mornings at 10 a.m. If you would like some more CircuitPython action, that is where you can find me. Hope you have a good rest of your day, good rest of your weekend, and all of that. And I will see you later. Thanks.